Hello and welcome back. In today's video, we are going to cover what is a property, system property, what are various types of properties, which means extensive, intensive properties, total specific properties, dependent, independent properties. Then we are going to learn about what is a simple compressible system, and the video will be concluded with what is a state postulate. So let us begin. So we'll start with what is a property. So what is a property, or what is a property of a system? So any measurable characteristic of a system is what we call a property. So two things. Property is characteristic of a system. It has a specific value for a system, so it's a characteristic of a system, and this characteristic should be measurable. So any measurable characteristic of a system is what we call as a property of a system, which means the system is a measurable characteristic. So what does it basically mean? For example, suppose when we want to describe a person, we describe it with features like height, weight, age, etc. These are the features of the person, characteristics of the person, which describes and which tells us what the person looks like or what the person is like. Similarly, we have a system, and when we want to know how the system is like, we use its characteristics, its features that we use for this person. We use features like temperature, pressure, volume, etc. Just like these features tell us how the person is like, similarly these characteristics of the system tell us how the system is like, in the same manner. Now the difference between this analogy is that these features of a person do not change over a longer period. So when we say the person has this height, this weight, this age, this stays same for a longer period. But the properties of a system do not stay constant for a longer period of time usually. So especially when a fluid is flowing, what will happen is temperature may change instantly, pressure may change instantly, volume may change instantly. So these properties, these features of a person stay constant for a longer period of time, and these properties may change from one instant to another instant. So they have different values at different instants, depending upon the type of process, or there are types of processes for which all these properties stay constant for a longer period of time, just like these features. So that is the difference and similarity in this analogy. And just like the features of a person, if the feature of a person changes, that change tells us about the behavior of this person. For example, if at one instant the weight of a person was W1, or let us take a numerical value, say 50 kg, and after some period of time, after a long period of time T2, suppose its weight was 80 kg. Let us say this is just 30 days of period. So this change in property tells us a lot about this what person has done in this month. For example, it tells us since for 30 days the weight increased is exactly 30 kilograms, which is like 1 kilogram per day, which is not possible, but let us say 1 kilogram per day. So what does this change in property tell us about this person? It tells us many things. For example, it tells us this person has eaten a lot on daily basis. This person's activity was very low. The person was not active. Two things we know about this person, that so the person ate a lot and the person was inactive. Similarly, for a system, when when the properties, or when any property of a system changes from one value to another value, from T1 to T2, this tells us a lot about the system. Or pressure changes from P1 to P2. Similarly, other properties. This change in property tells us about the behavior of the system, that what has happened. If temperature has increased, maybe the heat has transferred into the system. Pressure has increased at constant speed of the. For example, if the liquid is flowing, at the speed has remained same, but the pressure has increased, which means the energy has been added to the system. Mechanical energy has been added to the system, which has caused this increase in pressure. We don't know about this, whether heat transfer has occurred into the system, or energy has been added, mechanical energy has been added to the system. We don't know about them, but because we have seen that this property, this temperature increased, we concluded heat has been transferred into the system. Or the pressure has increased, we concluded at a constant speed of the liquid, pressure has increased, which means the mechanical energy has been added. So change in these properties tell us a lot about the behavior of the system, how system behaves or have behaved during this course of time. So this is the definition of property of a system. So any measurable characteristic of a system is known as property. So this the different properties of a system at a particular instant of time tell us how that system looks like, or how that system is like at that particular instant. Next is types of properties. So next, we have various types of properties. For example, extensive versus intensive properties. Now, those properties which depend on mass of the system. And there are some properties which do not depend on mass of the system. Properties which depend on mass of the system are called extensive properties. Depend on mass of the system. And the properties which do not depend on mass of the system are called intensive properties. For example, how do we recognize? For example, there are properties like temperature, pressure, volume, mass, density. And there are some properties among them. If we partition this system, if we divide it into two parts, there are some properties whose value will be divided, and there are some properties whose value will not be divided because of this partition. So the properties whose value will be divided are obviously depend on mass, and the properties whose value does not depend on mass, due to this partition, their value will not change. For example, when we divide it, obviously its mass will be half of what it was, and its will be half of what it was. So mass is an extensive property. Similarly, volume will be obviously divided. Its volume will be half, and if the partition is if this partition divides it into two equal halves, so its volume will be half. So mass and volume are extensive properties. Now, temperature obviously will not be divided. What was temperature before will be same after the partition, and pressure will be the same, density will be the same. So these are the intensive properties: temperature, pressure, density. So the properties which depend on mass are extensive properties, and properties which do not depend on mass are intensive properties. Now, total and specific properties. Now, what is a total property? And what is a specific property? Now, total energy of a system, total volume of a system, total mass of a system, these are called total properties. For example, this is a system, whether solid, liquid or gas, and its total energy is, suppose its total energy is E. So since the E is its total energy, therefore this energy is called a total property. So total volume, total property; total energy, total property; total entropy is the total property; total enthalpy, total property. So these are called the total properties. And if we if we talk about mass, for example, this system has total energy capital E. So this is the this is the total property of the system. Now if we find the total energy of only unit mass, suppose this room has some air and it has some total internal energy, so that will be the total internal energy capital U. Now if we only find the internal energy of unit volume, if we take 1 meter cube volume of this room only, 1 meter cube volume of this room only, what is the internal energy of this unit volume is called a specific property. Whether it's internal energy or whatever is called specific internal energy. If we are talking about enthalpy, it will be specific enthalpy. So total property means the total value of the system of that property, and specific property means the value that the total value of that property of the system divided by the total mass. So that is the specific property. So if E is the total energy of the system, so E divided by M, which is denoted by small e. So E is the specific energy, which means E is the energy of the total system and small e is the energy of the unit mass of the system. U is the total internal energy of the system, and U by M equals small u is the specific internal energy of the system, which means internal energy of unit volume only. Of the entire volume, total property. Of the unit volume, specific property. And total properties are usually denoted by uppercase letters, capital letters, and the specific properties are denoted usually by lowercase letters, small letters, with the exception of temperature and pressure. With the exception of, I mean to say, not the exception in this case. The general rule is total properties are denoted by capital letters and the specific properties are denoted by these lowercase letters, small letters. And when it comes to extensive and intensive properties are denoted by uppercase letters, intensive properties are denoted by lowercase letters, with the exception of pressure and temperature. Pressure and temperature are intensive properties, which should be denoted by lowercase letters, but they are denoted by the uppercase letters. These two are the exception. Rest is same. Extensive properties with capital letters, intensive properties with small letters. Say in the same manner, total properties with capital letters and specific properties with small letters. This is because total properties are extensive properties and the specific properties are intensive properties. So extensive and total are denoted by capital letters, intensive and specific properties are denoted by small letters, with the exception of temperature and pressure. They are intensive, but they are denoted by capital letters. Then we have dependent and independent properties. Dependent and independent properties. Now, a system may have, say, two properties, say temperature and pressure. If we change the temperature of the system and pressure automatically gets changed. We're not changing pressure, we're just changing temperature. Pressure automatically gets changed. We say temperature and pressure, these two properties are dependent, they depend on each other. We cannot hold pressure constant and change temperature because they are dependent. Whenever T is changed, P gets changed. If that is the case, the properties are said to be dependent. And in contrary, if we can hold the pressure constant and can change the temperature, these two properties are said to be independent because we can vary them independently by varying one and holding another constant. So if that is the case, we say these properties are independent of each other. Changing one does not change the other property. So these were the types of properties that we use in fluid mechanics or in thermodynamics. Then we have, next thing that we have is what is a simple compressible system and what it has to do with these properties. Now, suppose this is a system, whether it is stationary or it is flowing system. It has different types of energies. For example, we call it total energy of the system. So this total energy consists of its internal energy. It consists of because of the height elevation difference, it has potential energy, and because of the speed at which it is moving, it has kinetic energy. It has kinetic energy, and because of the, if there is magnetic field, it has electrical energy, and it may have magnetic field, so magnetic energy, surface tensile energy, surface tension, etc. So there can be a system may poses different forms of energies, but the system which has for the system in which these special forms of energies are negligible or not present at all, these electrical, magnetic, surface tension, these forms of energy are negligible, and the system mainly possesses these internal energy, potential energy, kinetic energy, all these energies. Such a system is called a simple compressible system. Simple compressible system. So it is just a simple compressible system, the system that can expand, that can compress, expand, has mechanical energy, because that with the help of that mechanical energy it will be compressed, it can expand, it can compress. So this is called a simple compressible system. So in case of simple compressible system, there are no special these forms of energies that we obviously do not study in fluid mechanics. These electrical energy, magnetic energy, and other forms of energy, we call it simple compressible system. Now, what is special about the simple compressible system? There is a rule about this system, and that rule says if this is a system, and if we fix the value of two independent intensive properties, only two independent, the property should be independent that we choose. So that means we have to choose two properties which are independent and intensive, which means which do not depend on mass. So this rule says, there is a rule which says, if we fix the value of two independent intensive properties of this system, the value of all other properties becomes fixed automatically. This rule is called the State Postulate. So what does it mean? It means if a system has to be in thermodynamic equilibrium, when we say this system is a thermodynamic equilibrium, it has a fixed state. Suppose it is at a state 1. What does it mean? It is at a state 1, which means its intensive properties has a fixed value. For example, pressure has some fixed value, temperature has some fixed value, specific volume has some fixed value, specific energy has some fixed value, specific entropy has some fixed value. All these intensive properties of the system have some fixed value, which means this system is at some specific state. Now, if even value of one property changes, suppose if we heat this system and temperature changes from 20 to 100 degrees Celsius, so during this course of temperature change, the system is not at a particular state, but it is undergoing a process. So a system is in a thermodynamic equilibrium if all the intensive properties have same value, all these intensive properties have some specific value and the specific constant value which do not change. So this is at a specific thermodynamic equilibrium. Now, if any one of these specific properties value change, the system is not in a thermodynamic equilibrium, but during that change it is undergoing a process. We say it does a process. The system undergoes a process. What does it mean, system undergoes a process? It means either one or more of the intensive properties value is changing right now. And suppose it changes from 20 degrees Celsius to 100 degrees Celsius and stopped. That means the system was at a state 1, which means this temperature and value of other properties, and it underwent a process during which we supplied this heat, and it attained another equilibrium state. which is now the 100 degrees Celsius temperature, and the same value of all other properties. So system at state 1 means all the intensive properties have fixed value, and we heated it. That means temperature now changes from 20 degrees Celsius to 100 degrees Celsius. During this heating, we say system is undergoing a process, and here it was at state 1, here it will attain a state 2. So when the system is at a particular state, the properties of intensive, the value of intensive properties is fixed. If it is at a different state, which means the properties of intensive properties will again be fixed, but at different values. And during this change from one state to another state, we say it undergoes a process, and the process depends on which property is being changed or whatever. For example, here temperature is being changed by heating, so we will call this a heat addition process. This process, heat addition process. Or if the temperature is decreasing, so we will say it is a heat removal process, and all that. Now state postulate says we do not need to, in order to keep the system at an equilibrium state, we do not need to fix the value of all the intensive properties, because the value of all the intensive properties is automatically fixed if we just fix the value of 2 independent intensive properties out of all these properties. We choose 2 independent properties, intensive properties, we fix the value by somehow, all the value of all other intensive properties will automatically be fixed. That is the state postulate. So this was all about today's video: what is property and what are various types, and how can we fix the state of a system, and what is a simple compressible system, and how can we fix its state, and how can we make it to undergo a process. Thank you.